Before moving on, it would be helpful to look at some examples of formulas, just to get comfortable with how formulas work in logic. Obviously, P, Q, R, P1 are good examples of atomic formulas. But what about examples of compound formulas? Well, one formula might be R implies not P. And one thing we might do for clarity's sake, even though there is no ambiguity, is restore the parentheses in this formula. We can also represent our formulas as a tree structure. One thing we may be interested in is the scope of the operators. So we see that the scope of this not is this P, and the scope of this implies is the whole formula. We could illustrate scope to ourselves by doing underlines like this, but I think a better way is to draw a tree. So we see that this implies is at the root, because it has the broadest scope. So we write that implies at the top of the tree. And then to the left is R, and to the right is the not, because that's the next scope. And then attached to the not is the P. Let's look at another one. Let's look at the formula P implies Q implies P. We see that there are no parentheses to be restored in this formula, but we also see that we can illustrate it to ourselves as a tree. So we start with this one. We have implies. To the left we have P. To the right we have another implies. And to the left of that we have Q. And to the right of that we have P. So those are both fairly simple. Let's try something a little more complex. Let's try the formula P implies Q or R implies R implies not P. We see that the root node, the connective with the broadest scope, is this implies, so we'll write that at the root. To the left, we have P. To the right, we actually have this implies. Because if we restore the parentheses in this formula, we actually have this. And we see that this implies connects one formula over here and one formula over here. So we write down that implies. And then to the left, it has an or. And to the left of the or, we have a Q. And to the right of the or, we have an R. And then to the right of our implies, we have another implies, which is this one. And then to the left of that, we have an R. And to the right, we have a not with a P attached to it.